Section 4.4 is on complex numbers. So we have this thing called the imaginary unit. We call it I. It's this lowercase printed I, and it is equal to the square root of -1. It's not a real number, it's an imaginary number. And it's how we deal with having to take the square root of a negative number. As you've known up until this point, whenever we had the square root of something negative, we said there was no real solution. Now we have this concept of an imaginary number, I, which is going to be represented by a lowercase I, and it's just equal to the square root of -1. So what does that mean? So I is equal to the square root of -1, therefore I squared, or I times I, which would be the square root of -1 times the square root of -1, is equal to -1. So I squared is equal to -1. I to the third power is the same thing as I squared times I. Remember that when you're multiplying powers, you just add their exponents. So I to the 2 times I to the 1 is I to the 3. Now, I squared, we just said, is the same thing as -1, and I is just I. So I cubed, I to the third power, is -1 times I, which is equal to -I. I to the fourth power is I squared times I squared, because 2 plus 2 is 4. Remember, I squared is -1, so that's the same thing as -1 times -1, which is equal to 1. So I to the fourth, and in fact, I to any power that is a multiple of 4 is going to be equal to 1, which is going to be very useful in a future problem here. So how do we use this? If I have the square root of -3, I can break that down and say the square root of -3 is equal to the square root of -1 times the square root of 3. Because remember, when we multiply radicals, we just multiply the stuff underneath. Well, I know now that the square root of -1 is I. Can't do anything with the square root of 3. So the square root of -3 is equal to I square root of 3. Square root of -16, pull out, it's kind of like pulling out a square root of -1. Square root of -16 is square root of -1 times the square root of 16. Square root of 16 is 4. Square root of -1 is I. So that's equal to 4I. So let's take a look at a couple examples here. Let's simplify each expression. So the square root of -18 is equal to the square root of -1 times the square root of 18. So my square root of -1 is going to become an I. 18, I have to simplify that. That's 9 and 2, 3 and 3. Remember, these guys can buddy up and come outside. The 2 doesn't have a buddy, he's got to stay inside, so that's going to be equal to 3 times the square root of 2. So now what I'm going to have in my final answer is I'm going to have an I, and square root of 18 simplified is 3 square root of 2. And here's how we kind of put those things together. We would do 3, which is the number in front, follow it by the I, and then follow it by the square root of 2. Sometimes I acts like a variable. It kind of acts like x. So in the same way that we would have put a variable out in front like that, we do that with I. So the square root of -18 simplifies to 3i square root of 2. Let's take a look at example 2 here. 3i times 4i. I'm just going to multiply this, multiply the regular number parts. So 3 times 4 is 12. I times I is I squared. But remember, we said I squared. We can go back and look at our chart here. I squared is equal to -1. So this is the same thing as saying 12 times a -1, or that's equal to a -12. Multiply the number parts, multiply the I parts. Okay, square root of -20 times the square root of -12. We need to do each of those separately. So 20 is going to break down into a 4 and a 5, and a 2 and a 2. That'll come out front. That'll stay underneath. I need to remember that I have an I in there for my -1. So that's going to be 2i square root of 5. That's just what the square root of negative 20 simplifies into. Let's do the same thing with 12. I have a 4 and a 3, a 2 and a 2. Don't forget your I. 2 comes out front, 3 stays underneath. That becomes a 2i square root of 3. Now let's multiply our numbers out front. That's going to give me a 4. Let's multiply my i's. That's going to give me an I squared. And square root of 5 times square root of 3 is square root of 15. Let's clean up that square root of, the I squared gives me a negative 1. So that's going to be negative 4 square root of 15. Okay, number 4, I to the 31st power, I raised to the power of 31. Now remember, from our chart back here, I to the 4th was equal to 1. And in fact, I to any power that is a multiple of 4 is going to be equal to 1. So I to the 8th, so for example, if I had I to the 8th, that's the same thing as I to the 4th times I to the 4th, which is just 1 times 1. So this can be very useful. So I'm going to think of I to the 31st power as I to the 28th power times I to the 3rd power. Because 28 plus 3 is 31. And remember, those are the rules for dealing with multiplying powers. So I to the 28th, just in case you're not sure, is I to the 4th to the 7th times I to the 3rd, because remember 28 can be expressed as 4 times 7, and when you have an exponent inside and an exponent outside, you multiply. So this is the same thing as saying 1 to the 7th power, since I to the 4th is 1, and I to the 3rd is the same as negative I, or we're still saying 1 times negative I, or my final answer is a negative I. So just break it down into a power that is a multiple of 4. Now let's use the imaginary unit to solve an equation. Let's solve 4x squared plus 32 equals 0. So like we did in the previous section, since this has two terms and I'm seeing 4 and 32, I'm just going to factor out a 4. Okay. Since there isn't an x out front, I'm going to divide both sides just by 4 here. Remember, 0 divided by 4 is 0. So x squared plus 32 equals 0. Wait a minute, I made a big mistake there. Sorry about that. Hold on. Let me go back. That's not a 32, that's an 8. Okay, that's much better. Sorry about that. Divide both sides by 4. There we go. X squared plus 8 equals 0. I thought that looked a little strange. Okay, solve this. I'm going to subtract 8 on both sides. And then from here I'm going to take the square root of both sides. And remember, when you take the square root of both sides, you need to do a positive or negative. On the left, the square root and the square cancel each other out, so I have x. And on the right, I get to use my imaginary unit. So I have plus or minus I times the square root of 8, because the I takes the place of the negative square root of 1. Square root of negative 1. 8 can be broken down into 2 and 4, and 2 and 2. Or I can write this as plus or minus the 2 that goes out front, and the I, and a square root of 2. And remember, that is two solutions: positive 2i square root of 2 and negative 2i square root of 2. Now, a complex number is a number that can be written in the form a plus bi, where a is the real part of the number and b is the imaginary part. So this actually has two parts to it. It's going to have a number out front, and that's real, just a plain old integer. It could be positive or negative. And then a plus or minus in the middle. and then the imaginary number here, so I multiplied by some number. This is complex because it has a real part and an imaginary part to it. So here's an equation that uses complex numbers. Find the values of x and y that make this equation true. And the equation looks pretty sloppy, and it's got parentheses, and you think you might want to distribute, but don't. But let's look closely at this. Notice I have a term here, two terms here, 5x plus 1, and then I have a term here in parentheses, 3 plus 2y, followed by an I. I have the same thing over here, two terms, 2x minus 2, and then stuff in parentheses here, followed by an I. Here's the way this works. This is my A. That's my real part. This is also my A. That's the real part. This is B. And notice how it's followed by an I. And this is B. And notice how that's followed by an I. So what I really have is two complex numbers that equal each other. A plus B times I equals A plus B times I. So since this is an equation, both sides are equal to each other, so the two real parts are going to be equal to each other, so the two A's equal each other, and the two imaginary parts equal each other, the two B's equal each other. So I can write this as 5x plus 1 equals 2x minus 2. I took the pink stuff and set it equal to each other. I can also say 3 plus 2y equals y minus 6. I took the two purple parts and set them equal to each other, and now it's very straightforward to just go ahead and solve, in this case for x. And in this case for y. So what is this saying? When x is -1 and y is -9, the two sides of the equation are the same. This complex number equals this complex number. The trick to doing this problem is to recognize what's the real part and what's the imaginary part on each side of the equal sign. Now, to add and subtract complex numbers, you want to combine the real parts and then combine the imaginary parts. So I have two complex numbers here, 4 plus 6i, and I'm subtracting from that the complex number -1 plus 2i. So I've got real imaginary minus real imaginary. So I'm going to take this negative and I'm going to turn this into an addition problem and distribute that. So 4 plus 6i plus 1 minus 2i. So just distribute that negative. Now I'm going to combine my real parts, which are 4 and 1, which gives me a 5. And then my imaginary parts, which are a positive 6i and a negative 2i, which is 4i. And that's it. So again, just recognize what are the real parts, what are the imaginary parts, and combine those. And notice that we always write the complex number with the real part first, followed by the imaginary part. Now to multiply complex numbers, we basically just FOIL. Treat it as though it were two binomials and we're just multiplying them out. So simplify 2 minus 4i times 3 minus 2i. So 2 times 3 is 6, that's my first, my outer, my inner, and my last, a positive 8i squared. Negative 4i times negative 2i is a positive 8i squared. So this is going to give me 6 minus 16i. Now remember, I squared is -1, so this is the same as saying 8 times -1. Or -8. And not quite done yet. I need to continue to combine my real parts. 6 minus 8, -2, minus 16i. Make sure that your real part is in front and your imaginary part follows. And to divide complex numbers, we're going to multiply by the conjugate. And you'll probably remember this from when we did some radicals. You take what's in the denominator, and whatever the sign is in the middle, you multiply by the opposite of that. So to simplify, 2i divided by 3 plus 5i, I'm going to take that expression, I'll rewrite it down here, and I'm going to multiply it by a 3 minus 5i over 3 minus 5i. Remember, I'm just multiplying by 1 since it's the same thing on top and bottom, but by multiplying by the conjugate, by keeping the numbers the same but changing the number, or I'm sorry, changing the sign in the middle, I'm going to get rid of the complex parts. So on the top, I'll go ahead and write this out. On the top, I will end up distributing, and then on the bottom, I will end up foiling. And that's going to give me 6i minus 10i squared. I think I'm going to have a lot of cleaning up to do there. And on the bottom, when I FOIL, 9 minus 15i plus 15i minus 25i squared. And the idea here is I don't want to have any i's in the denominator. So, cleaning that up a little bit more, it's going to give me 6i, and then remember this I squared is a negative 1, so that makes it plus 10 over, and on the bottom, which is why we multiply by the conjugate, these guys will cancel each other out. So I'm going to have a 9 minus, okay, so I have negative 25 times I squared, which is negative 1, which is going to give me a plus 25. So now I have 10 plus 6i, remember I want to write the real part first, followed by the imaginary, over 9 plus 25 is 34. And I can actually do some simplifying here a little bit more. I can take a 2 out of the top. That's going to give me 5 plus 3i over 34. I think I'm going to go down one more page here, give myself a little more room. And I can cancel. And that becomes a 17, which gives me 5 plus 3i over 17. And actually the way we like to write this is to break it up so that you can see the real and the imaginary parts side by side. 5 over 17 plus 3 over 17i. So the real part is 5/17, the imaginary part is 3/17 times I.